All right, so today our learning target is we're going to try and explain the meaning of area, and we'll do that by looking at some tiling patterns. And when you think of tiles, Linus, when you think of tiles, what do you think of? You think of anything in your house?
What do you think of when you hear tile?
I don't know.
Do you have tiles in your kitchen or the bathroom?
Like I said, are there tiles in the kitchen, like on the floor? Do I have tile on the floor?
No.
I do too.
You do. Just keep that in mind as we're going through this.
Okay.
So let's look at these patterns. Linus, do you see any? What do you think? Do any of them not belong together? What do you see when you look at these?
Which one does? Do any of them not belong?
Belong.
What do you see when you look at this tile right here?
The blue one.
It's blue. That's right. What about this one?
Yellow one.
It is yellow. So how is this one different
That's the blue one.
from this one?
Today.
Do you see any yellow over here?
I saw it.
Do you see yellow on the first one though?
Yeah.
No. Do you see yellow on A?
No.
All right, there's no yellow on that one.
That's blue.
You see any blue? You said this one was yellow. Do you see any blue on here on this one?
Yeah, I sure do.
Do you see blue on the B? No. Okay, you tell him.
No.
Right, there's no blue on that one. Now this one is a lot different than these two. What do you think? Do the shapes look the same on this one?
Yes.
They do? Kind of, but not really, right?
Kind of.
So this one, do you know what a pentagon is, Linus?
Do you know what a pentagon is?
Pentagon? No.
That is a shape with 5 different sides. So these shapes up here, or these tiles up here, both have pentagons in them. This one down here does not. This one, do you see all the white space in between here?
Look. Get up.
Yep.
Yeah. So that's different than these. There is no white space in these tiles up here. So now we're going to look at this pattern.
Wow.
Yeah, that's pretty cool, huh? All right, I'm freezing up here. Is your computer screen frozen too, or is it just mine?
No, mine's not frozen.
It's not?
Not really.
All right, here we go.
Okay, something soft.
All right, now we're going to look at the different shapes in here. We're going to look at the trapezoids, we're going to look at the rhombuses, and we're going to look at triangles.
Oh.
Do you know what a trapezoid is, Linus?
Triangles.
Yeah, trapezoid. It's this shape right here.
Oh yeah, triangle.
Yeah, there's a triangle right there. So the triangle has 3 sides. Trapezoid has 4 sides. These 2 sides are parallel right here. The rhombus has 4 sides, and these 2 sides are parallel. These 2 sides are parallel.
Rhombus. What's a rhombus mean?
He was showing you the rhombus.
Ah. Ow. Okay. Oh,
Linus, I apologize. My computer is really, really slow this morning. I think he's still asleep.
so sweet.
Okay, let's look at this. I'm going to show you some patterns in this little
Ow.
Listen.
tile right here. So if you look at that, it's really difficult to see. It all looks like it's just a jumbled mess. But if we look really closely, we can see a pattern emerge. So here we've got a hexagon, which is a shape with 6 sides. And there are 8 of those. So do these look all the same to you?
Those look all the same.
Yeah.
They look pretty similar, don't they? So we don't need to focus on all of them. Let's focus on one. How about that?
What is that?
So what we're trying to do, we're trying to figure out which shape covers more area in this hexagon here. We've got the red shape here. This is a trapezoid. We've got this blue shape here. This is a rhombus. And then we've got, looks like a green shape, which is a triangle. So which one do you think covers more of this shape than any of them? The red, the blue, or the green?
Red.
The red? Well, let's see. How do we know that? Well, let's find out. So the red shape.
Red shape. It's rhombus. Trapezoid.
Trapezoid. Yes, that's right.
Triangle. And
Okay.
rhombus. Is that rhombus?
Blue is the longest. Yes.
All right. This is not come up now.
Which one looks bigger?
Let's use this one.
Trapezoid.
There we go.
Good job.
Yeah, the trapezoid is bigger. Here we got a triangle. So there's 3 trapezoids, 1, 2, and 3.
Okay.
We've got 4 blue ones, which are the rhombus. 1, 2, 3, 4. And then we have 7 triangles, which is the green one. 1, 2, 3, 4, 5, 6, 7. So which number is bigger, 3, 4, or 7?
Which number is bigger? 3, 4, or 7?
3.
Bigger.
7.
7, that's right. So you would think that we would have more, or that the triangles would cover more of this space than everything, because there's 7 of them. But let's look at it a little closer. Do you think any of these triangles will fit inside of this red trapezoid here? Let's see. Yeah, fits right in there, doesn't it?
Yeah.
Let's see if any more will fit.
Oh no. Oh no. Yeah.
Look.
Ow.
Yeah, we got another one in there. Look at that. You think any more will fit in there?
Yeah.
Yeah, well, let's see. You're right. So 3 triangles fit into 1 trapezoid. So let's see, you think any of the triangles will fit into this blue rhombus here?
Oh. Oh, that's blue. No, that's blue. Red.
All right, come on.
Oh. Is that?
Okay, we've got 1 triangle that'll fit in there. Let's take this one here. So we've got 2 triangles that'll fit in there. So what does all that mean? Well, let's go back to our PowerPoint. So how does the area of a trapezoid compare to the area of a triangle? What that means is how many triangles will fit into 1 trapezoid?
1, 2, 3.
3, that is exactly right, Linus. That is exactly right. So there's the trapezoid, remember? And you said 3 triangles will fit in there. That is absolutely right. Good job. Well, what about that blue rhombus? How many triangles did we say would fit in there?
Rhombus.
The blue. 2, that's right. So So there's the rhombus, remember? And then we said 2 triangles would fit in there.
And blue.
So let's go back and look at this, the overall pattern, the overall tile. And let's see if we can figure out how many or which shape covers more of the tile than the rest of them. We thought maybe it was the triangle because there are more triangles, but we need to look at how each shape is related to each other. So how many triangles did we say we had?
Go back.
How many triangles are on there?
1, 2, 2.
Wait, count the green ones.
Now let's count the
1,
green ones.
2, 3, 4.
Okay.
5,
Watch.
6, 7, 8,
How many?
7.
7.
That's right. So how many rhombuses do we say? How many blue ones do we have here? We've got
1, 2, 3, 4.
4. That's right. And remember we said 2 triangles will fit into
Right.
1 rhombus. So how many triangles does that give us? If we were multiply 4 times 2, do you know what that is? That would be 8 triangles. So right now, if we were just to put a bunch of triangles in here, we would have 7 triangles if we just use the green ones. But if we include the triangles that would fit in the rhombus, we would have 8 there. So what about the trapezoids? How many did we say we had? 1,
Trapezoids. How many red ones?
1, 2, 3.
3. That's right. You remember how many triangles we said would fit in the trapezoid?
2.
How many do we have here?
How many? Look at this.
1, 2, 3.
3. That's right. So what we're going to do there is we're going to multiply 3 trapezoids times 3 triangles because that's how many we can fit into the trapezoid. And that would give us 9 triangles. So which one of these numbers is bigger here? This one, or this one?
Linus, what did he just ask you?
Which number is bigger? This one, this one, or this one?
8, 9.
9, that's right. So actually,
So actually,
the trapezoids fill more of the space because we can fit 9 triangles in there, and 9 is more than 8, and 9 is more than 7. So just to review, when you take a shape like this in a square and you put a bunch of tiles on, or you put a bunch of shapes together and they cover it up and there aren't any gaps, there's no overlaps, that's called tiling. Remember? Tiling, yeah. It's a bunch of tiles. Remember your grandma has tiles in her kitchen?
Remember, I got tiles on the floor.
No. Yes.
Yes.
Now, are there any gaps in your grandma's tiles in there?
Like, are there any big spaces in between?
Mhm.
No, there aren't.
So Linus, whenever you think of tiling, think of your grandma's kitchen floor.
Okay.
And then we looked at that pattern and we compared how we could take
Ooh,
different shapes, and I'll show you this here.
Henry, coffee tin.
Then we showed how we could move a shape
Yeah.
and compose another shape, and they would have the same area.
That's pretty cool, huh?
That's
Yeah.
pretty cool, huh?
Yeah, you gonna see that again?
That's pretty cool, huh?
See how it moves them?
See, we've got a square here and we've got 2 triangles. So
Yeah.
if we put the triangles over top of the square,
That's so cool.
that is cool. I think so too.
Yeah.
So we're doing this. When we're doing this, this kind of gives us an idea of maybe what area looks like. And it makes us think about how we can get area of a shape. All right. So what I'm going to do is I'm going to put an assignment on our Google Classroom, and you just there's really no right or wrong answer. I just want to see how you're thinking about area right now. So it's just one question. It asks you, one question, and it asks you what you think about area. So I will post that right after we're done here, and then you can turn that in whenever you get a chance.